Okie doke, we're doing midterm review. We're going to do these three questions that you see here on circular motion. Page 8, number 24, which ties in with question number 23, which is kind of an odd thing. A kid's sitting in the middle of a merry-go-round with a box out on the edge on this frictionless merry-go-round, and they're holding onto a string which is keeping the box from flying off. So the box is going in a circular path. Because the student is hanging onto that string. The thing to realize here is that this box has a centripetal acceleration because it's going in a circular path, and so it needs a force to keep it going in a path, and the student with the string is providing that force. So we're dealing with centripetal acceleration and centripetal force, and we're actually being asked to find out what the centripetal force is. So let's start off with an up chart. So this is number 24. And they tell me that the block is 1.2 meters from the center of the platform, which means the radius of the circle it's traveling in is 1.2 meters. The block has a mass of 2.0 kilograms, and it has a constant speed of 8.0 meters per second. It just accelerated because it's going in a circle. And we're being asked to find the force. Now, I'm putting FC here because even though they're asking for the reading on the string scale, I have to recognize they're asking for the force required to make this box go in a circular path. And that's the centripetal force. Centripetal is a fancy word for net force that means it's going in a circle. Now, the other thing this is going to remind us of is what we call the combo form of these formulas. The reference table gives us these two formulas. Fc is MAC, and the centripetal acceleration is v squared over r. You can, if you want to, plug in these two numbers, the r and the v, into the first formula, calculate A, and then plug that into the second formula. But let's use the combo form that we learned, which simply means that I'm going to take Fc is m times, and instead of writing AC, I'm going to write what AC is equal to, which is v squared over r. So this is my combo form. So I can do it all in one step. So now I can put numbers in, and I get mass of 2.0 kilograms times v squared, 8.0 meters per second squared, divided by 1.2 meters. And when I do all that math, I get the force of, the math comes out like 107 or something, if I remember correctly, but it rounds to 110 newtons. They're doing this to 2 sig figs, and to 2 sig figs, that's 110 newtons. Okay, next page are the other two questions, 26 and 27, which are in a group. So I'm going to kind of do them both together here. They're not in a group. I'm sorry, my bad. So it's 26, and then I will do 27. Okay. An unbalanced force of 40 newtons keeps it blah, 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 spit object. Okay. I hope you watched the last one that I just did, because we're going to use the same combo form again. Let me up this problem. Unbalanced force of 40 newtons. That means it's a net force of 40 newtons. And since it's keeping something going in a circular path, I use a special name for net force. I call it a centripetal force. Keeps a mass of 5.0 kilograms going in a circle of radius of 2.0 meters. What's the speed equal to? And again, I'm going to use this combo form that I developed in the last problem. Really, really useful to use, mv squared over r, and I'm looking for v. So let's see, I'll multiply both sides by r. Fc times r is mv squared. Then I'll divide by m. V squared is FCR over m. And now I can plug in, if I can see what the numbers are. V squared is the force, 40 newtons, times r, 2.0 meters, divided by mass of 5.0 kilograms. And that gives me, let's see, 40 times 2 is 80, divided by 5 is 16. And I'm actually going to give you a bonus here. I'm going to make sure that the units work. This is always a good idea when you're doing these problems, when you have to do a CFU like this. If the units don't work, it means you made a mistake in the CFU. So do the units work? Let's see, I've got Newton, which is a kilogram times meters per second squared. That's what a Newton is. So I've got that taken care of. Times meters, all divided by kilograms. What happens here? The kilograms cancel. And up on top, I have meters over seconds squared times meters, which means that I have 16 meters squared per second squared. That makes me happy because it's v squared. The last thing I do is square root both sides. I get v is 4 meters per second. That makes me happy. Choice D. Okay, last one, 27 is 27. Okay, the speed of the car, choice of square, what happened back. Blah, blah, blah. Again, I'm going to use the combo form. FC is mv squared over r. And this is a question where they're asking me what happens if the speed is double, and what happens to the size of the centripetal force. They're not asking me for an actual number. And by the way, if you saw the first video, I'm using the same method that I did there with the gravitational force questions. In any event, they're not asking me for what the new number is. They're just asking me for how it changes. So the easiest thing to do here is to make up numbers and then make the changes they suggest and see how the force changes. Here's what I mean. The centripetal force, and again, I don't care what the actual number is. I just care how it changes so I can make up whatever numbers I want. I'll make up the easiest numbers I can, which is 1. Mass is 1, velocity is 1 squared, radius is 1, so I get an original centripetal force of 1. Now I'm going to see what happens when I change. Let's see if the speed of the car twice as great. So now I'm going to write the same formula, but I'm only going to change the speed. The mass of the car hasn't changed, that's still 1. Now I'm going to put in v squared. Well, the speed now is twice as big, but that's squared because the formula says v squared, and they haven't changed the size of the circle, that's still 1. And so the new centripetal force is 1 times 2 squared over 1 is 4. The new centripetal force is 4 times as big, which is choice D. We are done.